A current transformer, quite simply, is used to transform the primary current quantity. It takes the magnitude and angle of the current and transfers it as it is from the primary to the secondary, but it reduces the current values. All right, that's great. Now, the other very important thing is that the primary winding of the current transformer is connected in series in the circuit. Yes, in series in its circuit, right? Right, engineers, its primary circuit or its primary winding is connected in series with what? With the power circuit, and the number of its windings is what? It is few, while the number of windings in the secondary is what? It is what? It is large. And of course, we know that your equation is quite simply that the secondary current over the primary current equals the primary turns over the secondary turns, or the relationship is inverse in the case of the current transformer. Very nice. Now let's take a look at each aspect, the types of current transformers. There are three types of current transformers for me, which are the wound type, then I have the window type, also known as the toroidal type, and then I have the bushing type. Let's take a look at each one, and then come back to discuss each part specifically. If I come to the first type, which is called the window type, or also known as the toroidal type, which is the ring type. All right, this ring type doesn't necessarily have to be a circular ring, but the ring type itself is one of the types of the window type, or the toroid type, CT. So you might find a type that is a ring, and it could be like a square or rectangular, whatever the shape, whether it's a square or a rectangle, it doesn't matter to me in the end. What's important is that it is, for me, a ring shape, all right, or what they call the window type. The idea here with this current transformer, remember I told you we would talk about each part separately. I just mentioned the primary winding to you a while ago, and I told you that the primary winding is connected in series in my circuit, right? Very good. But this type of transformer, which we call the window type or the toroidal type, for me, or you are bad for me, it doesn't have a primary, meaning the CT that I buy is essentially a core, which is the part I'm talking about. This is the core, whose details I haven't discussed yet, and my secondary windings are wrapped around it. So it doesn't have a primary winding, but the place of the primary winding, or the location of the primary winding, is the empty space within the core. This means the core has the secondary windings wrapped around it, and the internal space is where the conductor, bus bar, cable, feeder, or whatever you want to measure the current of passes through. So the idea is quite simple. In this case, if I apply this explanation to what I have described, it means that I place it around the bus bar or around my cable. This cable is it's mine. Very nice. If in some cases, engineers, you generally find on your cables, when you come to install it on the cables here, let me show you. Or let me just point here, and let me enlarge this camera right here. Where is the magnifier? Yes, exactly. Let me see. Exactly. Here I'm talking about my own. If I'm talking about my type, we agreed that I have three types. For example, when I talk about my country, it means that I bring my own and place it here around what? Around my own or any other. Nice, very good. Regardless of its shape, whether it's a ring, a rectangle, or whatever its shape is. That's number one. Okay, number two, there's something called a split core. What is called a split core? As an engineer, it comes here in your cables where you find this cable, for example, the red phase, and for example, the yellow phase, and for example, the blue phase, and here they are connected to your cable in this way. This is the part of the switchgear terminals that are located here, and your cable is connected to them, which then goes to your load, or goes to the generator, or goes wherever. I have something called the split core. The split core CT is a CT that looks like this. Here it is. Like this, it's about this core. What is this core? I mean, you can open it, what can you do? And you can close it again. But when you come to close it together, you have here, I mean, you won't find, I mean, it comes to close again. Like this, it closes your entire core together. So we call this type a split core This split core means that the core can be reassembled again, ensuring continuity without worry, because the contact area is as large as possible to minimize resistance in this case. So here, engineers, this split core is installed here on cables like this in this location. Also, this feature makes it very easy for you to remove or reassemble it without having to disconnect the cables. Because with the regular type, which is a ring, as mentioned here in front of you, I'm pointing to it with the laser. Look here in your diagram that I'm referring to, you'll find that I'm telling you it's a ring. Therefore, you first need to bring the cable and start here with the cable, and the current transformer begins to be around the cable. So if you want to remove this current transformer, you have to disconnect your cable to be able to take the current transformer out of your cable. However, with the display core, you don't need to do anything. All you have to do is simply detach the core or its metallic heart like this. Great, very excellent. Now, let's reduce this shape. And this is what we call the window. All right, there's something similar to it, which is the bushing. So, what is the bushing? Well, this is also one of the very important things, and people sometimes get confused about it. The idea is quite simple. The bushing is installed in any place shaped exactly like this. Now, as an engineer, for example, you have in transformers, here's the transformer and here's the body of the transformer shaped like this. For instance, this is the main tank of the transformer. So this is the main tank of the transformer. All right, or let's say you are just on the gantry, for example, which enters your stations, and it appears just like this. All right, great. Now you have the internal transformer windings. Now you want to connect these windings to the feeder coming from the GIS, from the switchgear, or from any other place. So you will connect these two. Now the body of your transformer tank, it's metal, right? Metal. And at the same time, it's grounded. This part of the transformer is metal. And at the same time, this part is non-carrying current, meaning it's not supposed to carry any currents, right? And what else do you have? You have this grounded. So of course, when you're entering with this conductor to get in here, surely around you here is the tank body. So any moisture or dust, you must leave a distance between here and the tank body itself. If you leave a distance here like this, what happens? You are exposing the oil or opening the tank. So this distance, engineer, to connect these two together, this distance must be sealed. So how do you seal this distance? It can't just be left open, right? Or am I wrong? The other thing is, I can't just lower my conductor or my passport like this, because as I told you, the insulator between this body and the tank body will be air. Therefore, if you just connect like this without having what we call the bushing here, this is what we call the bushing. The bushing is simply an insulator that separates non-current carrying equipment or parts from another part that contains a conductor, which is supposed to carry the current, like the conductor you have here with the conductor inside. This is regarding the transformer, and then you have the lines that come to your station and enter the station, right? So outside the station, you have something called the gantry. Here, you will either take this line through something called the GIB, which stands for gas insulated bus bar, or you might take it down directly to an underground cable. All right, great. So to come here from the overhead transmission line, essentially, in essence, basically, you will follow the path and proceed and enter my station. You will either convert this overhead line into something called GIP, which is the gas insulated passport. This is essentially a conductor running inside these tubes filled with gas, specifically SF6 gas. So here it contains SF6 gas. Alternatively, you can convert this overhead line into an underground cable, and the underground cable will enter the station and connect to the feeder of your station. In both cases, now you want to connect this to the internal conductor present here, or you want to convert it from this to connect it to the cable. In both cases, you cannot connect it directly like this. The gantry structure is also metallic, and this metallic structure is grounded, and it is supposed to be from the straight level of the 8 emirate. That's why you always see the bushing here, which you connect above. Here you have the conductor terminal, and it is connected from inside here to your conductor, whether it's a cable or something else. It is designed in such a way that it provides insulation between the current carrying conductor and the non-current carrying part, which, as I mentioned, is grounded. And the non-current carrying part, as I told you, is grounded. Beautiful, very nice function. This is what we refer to as the bushing. Now, the type CT, which is abbreviated as a window type CT. In the end, it's a window type CT. What does window type CT mean? It means it doesn't have a primary. It has a core, and this core has secondary windings around it. However, its primary is the conductor on which you want to measure the current, whether that conductor is an overhead line, underground, or whatever it may be. It's just like a window type CT. Ilonto 5CT, 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 5CT. But as I told you, it is installed here, and then the current transformer is on the bushing. This is the shape of the bushing that you saw, or like the one I drew, which is in black or red on the transformer. Like this one here, for example, this is the bushing. So you have the conductor connected to it, and the conductor passes through it here. So you come here, see this. It's like a cross section, or you're taking a sectional view of the bushing internally. So if you take a cross section of the bushing internally, you'll find the conductor here as you see it. What you see here in light orange is your secondary winding, or this is the core, the iron core around which the secondary winding coils are wrapped. Great. Now I have a third type, which we call the wound type or the bus bar type. This is the type I have drawn here, where I cut my circuit, took my bus bar that came out, and then fed it into a transformer. This transformer has only one turn, just one turn, and then it exits from the other side. So it goes like this. Makes one turn inside and then exits once. This is the one that is physically, it is physically connected, meaning it has to be connected, but this one doesn't have a in series. With current, it is physically connected, meaning it has a primary, and its primary must be connected in series. But this one doesn't have a primary. So the primary itself is the conductor or your cable, but this one has a primary winding, and the primary winding has two terminals, as you can see. These two terminals are what you will connect in series with what? In series with what? The thing from which you want to measure the current. This is what we call the wound type. Great. So let's not forget the three types of current transformers. You have the wound type, which is the one with a primary that consists of a single loop. Then you have the other two types, the window type or toroidal type, and the second type, which is the bushing or bushing current transformer. The bushing or BCT is the bushing current, a bushing current transformer. So if I talk about their types, to cover the topic of the primary, they all have a coil or iron core wrapped with secondary windings. They all have the same feature, but there are two types, the bushing and the window, that do not have a primary. Their primary is the cable itself. In the window type, the primary is a bus bar wrapped with a single loop connected in series in the circuit like the one I drew. So I've covered the first part, which is the primary of the current transformer. Nice, very excellent.